So we learned this lesson on Thursday. We started off with a warm-up, looking at the value of a truck decreasing by 15% each year. And I asked you to write a model. And oftentimes students are confused by this word model. Really it just means write an equation for the value of the truck. And then use that model to estimate the value after 5 years. So we did that. And this would be the answer. And we talked about how you could really use either of these formulas. If it doesn't say the word compounding, then n just equals 1. And then this formula turns into that one, with this being our initial amount and 1 plus our rate. But in this case, it wouldn't be 1 plus the rate because the value of the truck is decreasing. We're going to subtract. And we have to be really careful. Change that 15% to 0.15. Change it to a decimal, move that decimal 2 places to the left, and you're 1. So 1 minus 0.15 to the t power. So this would be the model, and I'm using the variables that they gave me. V is a value, and t is time. And then it asks, well, after 5 years, so I plug in 5 for t, and you might ask, well, where did you get that 0.85? I just simplified this right here. 1 minus 0.15 is 0.85. So it's a little simpler. So this to the power of 5, you need to do that exponent first and then multiply it times 29,000. And your answer is not complete without a dollar sign for talking about money. Alright, so then we looked, homework answers. Alright. Then we looked at continuously compounding interest. So A equals PE to the RT, and I had you guys predict, and you kind of can figure out on your own. A is amount, and P is principal, and R is rate, but we need to make sure as a decimal, and T is time in years. So if we identify all the variables, we can plug them in and find if we're compounding continuously. So here's a problem we tried. You just inherited $15,000 and you place it into an account that pays 4.5% interest. And it's compounded continuously. So when we see those two words together, compounding continuously, we need to think PERT. A equals PE to the RT. And I think some of you guys had to say it 10 times. Compounding continuously, PERT. Compounding continuously, PERT. Compounding continuously, PERT. You gotta hear it a million times before. No, I think they say 36 times you have to hear it before you really remember it for good. So if you want to say it 36 times, then you'll really remember it for the test on Thursday. But we want to find what is the balance after 2 years. So our T is 2. Our R is a decimal, 0.045. And we need to raise e to the power of that product and then multiply times 1,500. And we get the amount is 16,412 and 61 cents. We also talked about, well, this is the amount in the account, but if all I was asking for was the interest, then I would want to subtract off that 15,000 that I started with, because I didn't earn the bank didn't pay me $16,000. 15,000 of it was mine, or yours, and they only really paid you 1,412, which is really very good. But interest rates are not that high right now. Okay, so then we looked at this a little more complex problem. It referred to the same one in the beginning. So it's comparing what if we compounded monthly or compounded continuously. So when we're compounding continuously, you're going to use PERT. Oop, I lost some pieces there. Let's try that again. Okay, so if you're compounding continuously, using this formula here, and if we're compounding monthly, then we're going to use this formula here. So our n is 12. So we plug in 12 for n, change our rate to decimal, 2 places to the left. Principal, 12, and I asked, well, after 20 years, what's the difference in the two accounts? So I find how much in this account, find how much would be in this account. So 36,894. Now, there's something not complete about these. I'm going to make sure you have to put the dollar sign. But the question asks, which account should you invest your money in? And, well, I guess if you're trying to earn more money, then you would invest your money in the compounding continuously. The difference in the two accounts after 20 years is just $62.05. But compounding continuously gets them more money. Alright. Then we looked at this. Alright, this is a problem on your worksheet number 7. It's saying, well, at what rate would you need to find an account to make $1,500 grow to $20,000 if it was compounded quarterly over 18 years? So we identified, do I have it hidden here? No, I didn't. Okay, so we identified what is each of these. Well, this is our starting amount, so it's our principal, and this is our amount that we really want in the end. And then quarterly, that's our N, and this is our T, our time. And the rate stays as a variable. So then we need to get rid of our P, so we divide out the P, and then to get rid of this exponent, we take that root. So we end up being like to the 72nd power. So we're going to take the 72nd root, or raise it to the reciprocal power, 1 over 72. So we have to use all that stuff we learned in the last unit to isolate r. So once we take the root of both sides, we can subtract 1 and multiply by n to get that fraction to cancel out, and we find our rate. Now the rate is as a decimal, and you need to change it back to a percent. So you should get 14.65%. And we went over that in class, so you should be okay with that. Alright, but come see me if you're not. Alright, and then we had an exit ticket, very similar to the warm-up. Either of these would be acceptable answers for the model. You can put 0.91 or 1 minus 0.09. And after 3 years, you must have the dollar sign for it to be accurate. And that's how much the RV would be worth after 3 years. And you want to really consider, okay, the RV started at 37,000. Because I had a couple students tell me that the final value, after it was decreasing in value, the final value was 49,000. Does that make sense? We started at 37,000 and the value decreased, and now it's worth 49,000. But it doesn't really make sense. So we want to make sure that our answer makes sense. So yeah, okay. So after what, 5 years? No, after 3 years, it's depreciating by 9%. 37 went to 28. Okay, that sounds reasonable. Okay. All right, I think that's it. Okay.